guys, Mrs. Traver here. Today we're going to talk about cube root functions. Yesterday we talked about square root graphs. Today, cube root graphs. So learning target, you'll be able to find the absolute value, and the cube root. We'll mess with both those again, and you'll know you're successful when you can make a table for absolute value, and you can use mental math or calculator to find cube roots. So today we're going to look back at our assignment from yesterday, take some notes on those cube roots and the graphs, and then do an assignment. So let's jump in and see our assignment from yesterday. Here's the first two graphs. Notice the first one went up one. I graphed the parent function as well as the new function where it went up one. The next guy I graphed the parent function, and then the new one where it went down 4. Notice I was plotting those points as I went. Like on this one, I knew there was a point originally at 4.2, and now there is a point at 4.3. The next slide, let's see the next two problems. Here we go, some more graphs. This one, it flipped. It went across the graph, and then it also went down 2. Next guy, it flipped, and it went up 3. So my red one is the answer. The back was some review problems. So the first couple were diamond problems, and then there were some absolute value solving and some regular solving. There were a couple no solution problems in there. And lastly, the last two solving and some stuff on the quadratic graph. So those are our assignments, or questions from the assignment. If you have any questions, see me on Zoom and we can go through any problems you like. Moving forward, let's see, cube roots. Let's see, we have never seen something like this before. So this is something new and fresh, and I want to try to give an idea of what's happening here. So before I mention this one, I want to mention a root that we normally see. We normally see, for example, the square root, and there's no number in here. Well, there is, but it's like invisible. This is the square root of 4. If you see no number, it's a 2, so it's like hiding in that little corner. Similar to how if I were to say you have x, you know you have 1x, but we don't put the 1 there. So it's this invisible math that's happening that we don't write just to make ourselves a little bit faster when we write it. So the square root is asking ourselves what times itself is 4. And we would answer 2 for this one because the square root of 4 is 2. This is asking us something different. This is asking us what times itself 3 times. There's where the 3 comes into play. What times itself 3 times is 8. So we want something times something times something, and it's the same something every time, that equals 8. So they're kind of trippy to think about, but let's just jump through. If it was 1, it'd be 1 times 1 times 1. That does not equal 8. Let's try 2. What about 2 times 2 times 2? That would be 4 times 2, or 8. That checks out. So the cube root of 8 is 2. And that works because 2 cubed is 8. These are backwards from each other. These are inverses. So the cube root and cubing something, these are inverses. They undo each other. They flip-flop back and forth. Let's try some more and you'll see what I mean. So the cube root of 27 is asking us ourselves what cubed is 27? What times itself 3 times is 27? So we can kind of jump through them. 2 times 2 times 2 we did in the last one was 8. Let's try 3. 3 cubed is 3 times 3 times 3, which is 9 times 3, which is 27. So 3 cubed is 27. So therefore, the cube root of 27 is 3, because this is asking us what times itself 3 times is 27. So we're going backwards with our exponents here. We're going to keep chugging along and try some. What about this guy? What cubed is 30? Take a minute, pause your video, try it on your calculator, try some numbers out. 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4. See if you can get something that gives you a 30. Pause now and try it. Okay, did you get anything? Me neither, because there isn't a pretty number that cubes to get 30. Our calculator actually has a function where we can mess with this a little bit. So notice here you've got the square root button. On your calculator, actually what I'm going to do is I'm going to pull up the Desmos calculator because it's got a nicer way of looking at it. So from my website, if you go to resources and this scientific calculator, what we want to do here, I'm going to make this a little bit smaller, is we want to do the cube root, right? Because if I'm trying to solve for t and I want t by itself, I could cube root both sides. That way the cube root and the cube go away and I just have t equals the cube root of 30. And if I could type this in my calculator, I'd be good, just like I can type in square roots. And we can type that in, but let's see what happens when we do it. I think there it goes. So the cube root of 30. Notice here you've got the square root. It's there for you already because you use it so frequently in math. This one has the square root with an n sign, and it's already ready for you to type a number in right there to the corner. I want a 3 and a 30 here. And then here's my answer, 3.107, blah, blah, blah. This actually goes on and on forever. So this isn't a really pretty answer, but the t in this case would be approximately equal to, I already forgot what the number was, 3.12, we'll say about, 3.12. So some of them don't work out pretty. We're going to work on pretty ones today, but I just wanted to mention that not all numbers work out pretty, just like the square roots don't either. All right, let's try another one. What is the, what's going on here? The square root of 64 squared. Well, let's talk inverses again. If you square root something and then you square it, you're just undoing what you just did. It's like as if I said x plus 2 minus 2. These would cancel. That's what's happening here. If you take the square root of something and then square it, these two things just cancel out and you just get 64 out. Same kind of thing here. What is the square root of 19 squared? Well, the square root of anything and then square it is just itself. Your calculator will tell you the same thing. If you try to type this in, you're getting a little lost. Let's see what would happen. I want to do the square root of 19 squared. So I've got the square root of 19, blah, 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 and then I'll square it, and it's 19. So it just undid itself, is my point. Let's see what's up next. We've got a couple that I want to look at graphs for. So notice there's a link here. We're going to look at the cube root of x and then see what happens when we do plus 3. So let's see, I've got both from graphed already. Here's the parent function, like we did yesterday with square root of x, and we saw the parent function for that. Here is the cube root function, like way different. It's this little wiggle. And if you zoom out, notice this wiggle goes on and on forever. But it's got this cute little turn right here when we zoom in, right at the origin. And then if I do a plus 3, what do you think is going to happen? Like what happened with all of our square roots when we added something to the outside? It went up. So look at that. It did. It went up. There was a point at 0, 0, and now that point is up 3 as 0, 3. All of the points actually just moved up 3. So that's something to notice. Whoops, where'd my slides go? That's something to notice on problems like this is they just moved up. Let's see what's next. I think we're ready for an assignment. Today was rather quick, even though it was some weird stuff. Let's look at what this assignment looks like. On the top, it's some square roots, cube roots, roots in general to simplify. So there's someone here to try. Notice I challenged you once with something to the 4th. So see if you can ask yourself the question if you're getting stuck. This one's asking yourself, what times itself 3 times is 64? This one's asking you, what times itself 4 times is 16? Try out these ones, see how they go. No harm, no foul, but give them a shot. Then the rest of these are from our textbook. So we're solving for y. If you know what x is, plug it in, simplify. And some absolute value stuff, that's a review. Here's a pattern question, give that a shot. And then there's some more solving down here, and one where you're having to graph and see what happens, and then a few where you evaluate. That is it for today. I hope it looks okay for you, and you have a good rest of your day. I will see you tomorrow. Bye.